And this is the second lecture on class 11 maths chapter 2, which is relations and functions, and in this video I am going to give the complete solution of exercise 2.1, which is on Cartesian product of sets. So before starting the exercise I am giving a brief explanation about this ordered pairs and then equality of two ordered pairs and Cartesian product of sets. Ordered pair is any two elements written in first bracket in a specific order is called an ordered pair. Example, say 2, 3, two numbers 2 and 3 written in a specific order enclosed by first bracket. So this is an ordered pair. Say minus 3, 5. This is also an ordered pair, etc. Then about equality of ordered pairs. If any two ordered pairs are equal, say example, I'm taking an example, say x, y is an ordered pair is equal to another ordered pair, say minus 3 and 4. Then their corresponding components must be equal. That means x corresponding is minus 3, they must be equal, and y corresponding is 4, that means y must be equal to 4. So this is about equality of two ordered pairs. Then about Cartesian product of sets, taking an example, two sets A and B. Then A is the first set, B is the second set. We should not change the order, we must write in specific order. A is the first set, B is second set. I have written in the specific order. Then the Cartesian product is found like this. 2, 5 will make the first pair. 2 next element, that means 2, 6 will make the next pair. Then 3, 5 is another pair. 3, 6 next pair. Then with 4, 4, 5 is next pair, and 4, 6 is another pair. So Cartesian product of two sets is the set of all the ordered pairs in which every first element is from the first set and every second element is from the second set. So this is about the Cartesian product of two sets, which in a detail I have given explanation in the first lecture. Starting with the first question, one ordered pair is given equal to, this is one ordered pair equal to another ordered pair, and you are asked to find the unknown, that means x and y. And we know if two ordered pairs are equal, say xy is equal to 3, 2, then x must be equal to 3, first component must be equal to the first component, and second component must be equal to the second component. This is about the equality of two ordered pairs. Now here given this is one ordered pair equal to another ordered pair, then we can apply this concept. First component must be equal to the first component, that means x by 3 plus 1 is equal to 5 by 3, and second component must be equal to the second component 1 by 3. Now we can solve and find out the values of x and y. Here taking LCM, x plus 3 equal to 5 by 3, 3 getting cancelled, x plus 3 is equal to 5, and x is equal to 5 minus 3, so x equal to 2, and then you can solve and get the value of y also. This is about the equality of ordered pairs. Two ordered pairs are given equal, then first component equal to the first component and second component equal to the second component. So question number 2, if the set A has 3 elements and set B is given, then how many elements will be there in A into B Cartesian product? We have discussed in the first video, if set A has m elements and B has n elements, then the Cartesian product A into B will have m into n elements. You can take an example, if A has 2 elements, B has another 3 elements, then A into B will have 2 into 3, that means there will be total 6 elements. Now in this case set A has 3 elements and set B is given. Here also we have how many elements? 1, 2, 3, 3 elements. That means m value is 3 here and n value also is 3. Then set A into B will have m into n, that means 3 into 3. That means there will be 9 elements in the Cartesian product of A into B. There will be total 9 elements. Question number 3, set G is given, set H is given, and we are asked to find G into H Cartesian product and H into G, that is the Cartesian product. So first I have written G is given, H is given, then G into H. We should not change the order. First is G, I have written, second is H. Then it is the set of all ordered pairs from first to second. That means 7, 5 making the first pair, then 7 with 4, 7 with 2, then next element 8, 5 pair, then 8, 4, and then 8 with next 2. It is the set of all ordered pairs in which every first element from first set, second element from the second set. Then we have to find out H into G. That means first is H now, and then second is G. Then same way from first to second, 5, 7 is making one pair, 5 with 8, then 4, 7, 4, 8, then 2, 7, 2 with 8. So this is also the set of all ordered pairs in which every first element from first set and every second element from the second set. So this is how we find the Cartesian product. And then the question number 4. Question number 4.1. Set P is given, set Q is given, and then it is given that the product is P into Q given by this set, and we are to say it is true or not. It is Cartesian product of P into Q. Now P is given, let us say it is true or not. P is, let us find P into Q. P into Q. P is the first element M, N, first set with elements M, N. Second set Q, it is with N, M. Then if we find the Cartesian product, we know it is formed by all the ordered pairs from first to second. So Mn will make the first pair. Then M into M, M making the second pair. Then again with N first, N making another pair, N into M another pair. Now if P is Mn, Q is Nn, we have seen this is the Cartesian product. This is the Cartesian product of P into Q. But P into Q is given different. So this is not correct. This should be the correct answer. Then 4.2, it is given like this. A and B are two non-empty sets. Then Cartesian product A into B is non-empty set of ordered pairs XY such that X belongs to A, Y belongs to B. It is actually the definition of Cartesian product. Definition of Cartesian product is like this. If A is a non-empty set, B is another non-empty set, then A into B is given by all ordered pairs XY such that X belongs to A and Y belongs to B. It is for all X belongs to. In definition, we must mention that it is for all X belongs to A, Y belongs to B. It may be only for some element also. So if it is only for some elements, that is not the Cartesian product. So we must mention the word for all. So according to that, this should not be correct. It is not true actually, the statement given, but in the book it is given, it is true. But according to definition, we must mention that it is for all X belongs to A and Y belongs to B. Then only it makes the Cartesian product. And the way it is written, it is a relation. It is not Cartesian product. So according to definition, it should be not true is the answer according to the way it is written in the textbook. But in textbook answer is given true. This is, if we say it is a relation, then it is true. But if we say it is a Cartesian product, then we must mention it is for all X belongs to A and Y belongs to B. All possible ordered pairs makes Cartesian product. But here it is not mentioned for all X belongs to. It is only written that X belongs to A, Y belongs to B. It may be only for some elements. So if it is only for some elements, it is a relation, it is true. But else if we say it is a Cartesian product, then it is not true is the appropriate answer for this question. 4.3, the question is given like this. A is this, B is this. Two sets given, and A intersection A into B intersection phi is phi. Let us find it and then we will see it is correct or not. A into B intersection phi. That means I am taking the left hand side. What is set A? A is 1, 2, it is given, into two sets, I will put third bracket, B, set B is 3, 4, intersection phi, no element, empty set, and then this will remain same, and we will simplify inside bracket at first. Intersection means common in two elements, two sets, common elements in two sets. Here no element, so there is no element common, so it will remain phi only, and then if you take the product is the set of pairs, but there is no element in second set to make pair, and hence it will remain empty. So that means this given statement is true. Question number 5 is, if set A is this, then find A into A. Product of set A with itself 3 times. Product A into A. Then first we will find out A into A. A again A. Then all the ordered pairs first. -1 is a pair. -1 with next element is another pair. Then next 1 with 1 -1 is a pair. With 1 next element is another pair. So this is what we have got is A into A. Now 3 times A into A. We can make it A and A together. Then this A into A product we already have here. We can write it -1 -1 -1 1 1 -1. We are writing as it is, and then A into A. So with -1 all possible, now it will be triples, 3 together. -1 with first pair, that means it will be -1 -1 -1, first triplet. Then -1 with next pair, -1 -1 1. Then with the next pair again, -1 1 -1. Then with this -1 with next pair, -1 1 1. So with first element we have taken all the combination with all the pairs. Then with the second element 1. So 1 with the first pair, 1 -1 -1. While writing, you make sure that you are writing in specific order. 1 -1 -1. Then 1 -1 1. I'll write here 1 with this pair, -1 1. Then 1 with the next pair. This one with the next pair, 1 1 -1. Then with the last pair, what it will be 1 1 1. So this is how we find product of a set with itself 3 times. The next question is question number 6. It is given Cartesian product is given. Cartesian product of 2 sets A into B, all the pairs it is given, and you are asked to find the sets. So before we were finding given set A and B, we were finding the Cartesian products. Now Cartesian product is given, we have to find out the sets. This is the Cartesian product given. Now first set is the set of all the first components. Set of all first components. First component is here A, again A, but we should not repeat elements. In a set we cannot repeat the elements. So A, again A, we will not write again. Then B, then again B, we will not repeat. Set A, remember, first set, it is the set of all first components. Set of all first components. Without repeating, we cannot repeat elements in a set. Then B is the set of all the second elements, that means X, Y, then again X, again Y, we will not repeat. It is the set of all second components, and remember, without repeating, there is no repetition. Elements in a set cannot be repeated. So this is the complete solution for this question. Question number 7, it is given set A, set B, set C, set D, and we have to verify this. First part, verify this, and second part, we have to show that A into C is a subset of B into D. First part I am doing now, taking LHS, A into B intersection C. We will write the elements. What is A? A is given 1 2. Into 2 sets we will keep in bracket. B 1 2 3 4. Intersection C, C is 5 6. Now first set we will keep it as it is, and then the terms inside the bracket will simplify at first. This is intersection of the 2 sets. Intersection means the elements common in 2 sets, and we can clearly see there is no elements common in the 2 sets. So it is remaining 5. Now we will make the pairs of elements from first to second, but there is no element in the second set. So it will remain empty, that means it is 5. And then I can find out the right hand side. What is the right hand side? Is A into B intersection A into C. I will put the sets at first. A is 1 2 into set B, B is 1 2 3 4. Intersection, so I will keep it in bracket. Intersection A into C. Set A is 1 2 into set C 5 6. I will keep in second bracket. Now all the ordered pairs from first to second, 1 is the first pair, 1 with 2 next pair, 1 with 3 next pair, 1 with 4 next pair. Then with the second element again, all the pairs with second element pairing with the elements of next. 2 1 is the first next pair, 2 with 2 another pair, then 2 with 3, 2 with 4. So this is the first set. And then intersection with the, so I'll keep in bracket, intersection with the second is again 1 5 first pair, then 1 6 next pair, 2 5, 2 with 6 next pair, and then we can see clearly there is nothing common. 1 1 is in the first set, but it is not there in the second set. 1 2 also is not there, 1 3 also not there, 1 4 also not there, 2 1 no elements of first set is there in the second. That means there is nothing common, and which is equal to 5, and therefore LHS equal to RHS. This is the complete proof for the first part. Now second part, we have to show A into C is a subset of B into D. Subset means every element of A into C must be there in B into D. Then we can say A into C is a subset of B into D. So first I'll find A into C. A 1 2 into set C 5 6. Set of all the ordered pairs. We will make 1 with 5, one pair, 1 6, then 2 5, 2 6 another pair. So this is A into C. Then next is B into D. We have to find out B into D. What is B? Set B is given 1 2 3 4 into set D. D is here 5 6 7 8, 5 6 7 8. Now we'll find all the pairs. 1 5, 1 6, 1 7, 1 8, then 2 5, 2 with 6, 2 with next element 7, 2 with 8, all the pairs. Then 3 5, 3 6, 3 7, 3 8, and then with 4 all the pairs, 4 5, 4 6, 4 7, 4 8, all the pairs we have found. Now we can say A into C is a subset of B into D if every element of A into C is there in B into D. Now 1 5, is it there? Yes, it is there. 1 5 is there. 1 6, yes, 1 6 is there. Then 2 5, yes, it is there. 2 6, yes, it is there. That means every element of A into C is also in B into D. So we can write like this clearly: every element of A into C is also in B into D. We can clearly see all the elements of A into C is also there in B into D, and we can say, therefore we can say A into C is a subset of B into D. Subset, if we write mathematically, we can write like this, that is, we can write this is the symbol for subset. It is a proper subset. A into is a smaller, so this is the symbol for proper subset. So A into C is a proper subset of B into D, and hence it is verified. So this is the complete solution for this question. Next is question number 8. Set A is given, set B is given. Write A into B. That means we are asked to find Cartesian product. That is the first part. And second part is how many subsets will A into B have. So first I am giving the first part. A is given, B is given. We were asked to find A into B. That means the set of all the ordered pairs from first to second. 1 3 making the first pair, 1 4 next pair, 2 3, then 2 4. So this is the answer for the Cartesian product A into B, first part. Now second part asking how many subsets will A into B have. So we can clearly see this is set A into B. How many elements are there here? Here total 1 2 3 4, total 4 elements in A into B. and number of subsets of A into B, how many it will be there. This is about number of subsets that is done in the first chapter, set chapter. If a set A has m elements, m number of elements, number of subset, the formula is 2 to the power m. If a set has m elements, 2 to the power m. Now here A into B has 4 elements, so number of subsets will be 2 to the power m. That means 2 to the power 4. M is 4 here, and 2 to the power 4. That means there will be total 16 elements. If we find the subsets of A into B, we will get total 16 subsets. Question number 9. It is given A and B are two sets such that n of A is 3. That means set A has 3 elements, set B has 2 elements, and then these are some elements in A into B. You are asked to find A and B. What is given here? Given these are the elements of A into B. These are the elements in A into B. Then set A, that means the first set, it must be the set of all the first components. So what are the first components here? X, then again Y, again Z. We can write X, Y, Z because it is mentioned X, Y, Z are different elements. They are not same elements. The reason is in a set we cannot repeat the elements. So first set is the set of all the first coordinates or first components. The second set is the set of all the second components. What are the second components? 1, 2, and again 1. Again 1 we cannot repeat. Once written we cannot repeat the elements. Now in the question it is mentioned set A has 3 elements. So we can see here A has 3 elements, 1, 2, 3. So it is correct. Set B has 2 elements also here, 1, 2, 2 elements. So it is also correct. So this is the complete solution for the question. Next is question number 10. The Cartesian product A into A has 9 elements, it is mentioned, and some elements of A into A are given -1 and -1 0 and 0 1. That means this -1 0 and 0 1, these are the elements of A into A. First set is A, second set is also A. So every first component is in A, second component is also in A. Then set A must be, you see, all the elements must be in set A because first is A, second is also A. So whatever the numbers here, elements, first and second components, everything should be in A without repeating. So elements will be -1 is there, 0 is there, 0 I have written, will not repeat again, then 1 is there. So this is the set A. A has 3 elements, it is meant, so no. A into A must have 9 elements. That means A has 3 elements. 3 is a 9. That means set A must have 3 elements. So -1, 0 and 3. So it is correct. We got set A has 3 elements. Now second part is, if these are the elements of A into A, then what will be the remaining elements? Because in A into A, there should be 9 elements. A has 3. 3 3s are, there should be 9 elements. So what will be the remaining elements? So for that, at first I can find out A into A. So -1 0 1 into again with the same set itself, the product. Now all the ordered pairs, first to second, or we'll have to keep the order from writing from first to second. So -1 making the first pair, then -1 0, -1 1, then with 0, -1 0 0, 0 with next, that means 0 1, then with 1 all the pairs, 1 -1, 1 0 and 1 1. Now in the question you are asked to write the remaining elements. Remaining elements means except these two. So -1 0 except this element, and where is 0 1 0 1, this except these two we have to write the remaining elements in A into A. So we can write the remaining elements in A into A except this one and this one. When we say elements, then we should not write second bracket. It is not a set. We will write only the elements. The remaining elements are -1 -1, this one no, then next is -1 1, 0 -1, 0 0, this one we cannot write. Next is 1 -1, 1 0, then 1 1. So these are the elements. We should not write bracket. If we write bracket, it will be again wrong, because bracket represents set, and here you are asked to write only the elements. So these are the remaining elements in A into A, and this is the complete solution for this question. So this is the end of this lecture 2. in which I have given the complete solution of exercise 2.1, and in the third lecture I'll give the complete solution of exercise 2.2, which is all about the relations.